Okay, so moving on from there, we've covered a bit about kind of when you need to use probability sampling that's actually going to reflect population in question, um, and convenience sampling. But let's actually talk about the specific methods of probability sampling. Um, just one thing to remember is that probability sampling is not the same as random assignment. Just don't get those confused. Random assignment is going to be this over here, where you're doing an experiment and you randomly take people and say you number them off. You're going to be in group one, you're going to be in group two, so on and so on, and you're randomly assigning them to a condition. That's different than random sampling, where you're going to randomly pick people from the population to do your study. And that's this part on the left here. So maybe I take, randomly dial people up, end up with something that's going to be pretty close to population demographics. So kind of the simplest method is, of course, simple random sampling. And this is, like I've kind of been mentioning so far, just randomly selecting people from the population in question. Um, you can generally do this. This is easy to do with like surveys or phone surveys. Um, but other methods, you might have to get more creative. Or sorry, other populations, you might have to get more creative. But let's say you're just interested in interviewing um, anyone in the US or any adults. A simple method would just be, simple random sampling method would just be to randomly dial digits um, and get anyone you can to participate in the study. Um, so the logic here is that you're by randomly selecting people this way. It should be reflective of the probabilities because it's random. Um, should be reflective of the probabilities of the population. So, but it's not a guarantee. It's still based on chance. Um, so let's look at an example of that. Let's say that I'm going to, these represent some demographics, because let's say it's age, um, or it could be ethnicity or whatever. If I randomly pick people, so kind of a subset of this population, to be in my study, chances are that random selection should be about equal, should be reflective of population. So if there's a lot of blue circles here, and I'm randomly selecting people, chances are my sample is going to have a lot of blue people, just because probability wise, there's a lot of blue. Well, there's the most blue in the population. On the other hand, if I'm again randomly selecting people from this population, chances are my sample is going to end up with not very many red, because the probability of picking a red is low because there's not many um, reds in the population. So this is the logic behind simple random sampling. Again, if I'm just picking people at random, I should end up with this representative sample, at least close to representative, because the probability of picking different demographics is going to be reflected in how many of those I pick. That's kind of fancy wording, but again, the basics is just that if there's a lot of blue in the population, my sample, and I'm randomly picking people, my sample is probably going to end up with a lot of blue. Um, let's say I don't know the exact numbers here, but if there's, 30% green and I'm randomly picking people, well, I have a 30% chance of picking a green circle, and therefore my sample should end up with roughly 30% green. Okay? You'll see more of this if you do the extra credit activity on simple random sampling. However, one limitation of this method is that it's based on probability. So it's not necessarily going to be, well, it definitely won't be perfectly representative because things can skew. So for example, you know, although I might have more blue than orange, just based on probability, based on the random dialing, I might still end up with um, a little bit more orange than blue, right? Um, it would be much less likely, but it's even possible that I could draw, you know, all three reds and end up with more reds than blue. Very unlikely, but possible, right? Because it is based on randomly picking people. The randomly picking people is gonna most of the time give me, good representation, but it's based on probability, so it's not gonna be perfect. Um, and kind of the more representative, the less representative the sample might be, the less probability of getting that sample. That's kind of the general theory here. You probably don't need to know this, but being like a little bit off. In other words, being a little bit off is moderately likely, or I'd say pretty likely, but being way off is very unlikely. The more off you are, the more unlikely it is. So, just as an example, the probability of picking more reds than blues is very low, right? Because that's not what the population is. The probability of being, say, maybe picking more orange than blue is higher because that is what the split of the population looks like. So bottom line is that it's not going to be perfect, um, but it'll most likely be pretty close when you're randomly picking people. Another thing to bear in mind, and this is what I talked about when I said sample size and sample generalizability are not equivalent, but they can be related. Um, when you're dealing with a simple random sample, you know, it does, the more people you have, um, the less room for error, basically. So bigger sample sizes is more likely to make it representative when you're specifically dealing with simple random sample. Um, so to give you an example, let's say I'm looking at, um, I want to know what the height of the population is, right? Well, I'm going to randomly draw people, and let's say I only pick 5 people. Well, the odds of getting a bad estimate there are much higher than the odds of getting a bad estimate if I pick, say, 100 people, or 1,000, or 10,000. That's kind of the basic logic behind all probability is that more sample equals more representative. So it's going to be closer to the true number of the population. Again, if I pick 5 people, I might get a bad measurement. But if I pick 10 people, it should be better. But even better if I pick 100 or 1,000. It kind of keeps going up like that. The same thing applies to representativeness. So imagine these are a lot bigger here, but if I only pick like 10 circles, I might get a skewed measurement. I might get, say, more red than blue. Whereas if I pick 1,000, pretend there's like 10,000 of these, um, chances are it's going to be more representative if I pick the smaller sample. Okay. Okay. Another method is known as stratified random sampling. And this is when you actually divide people into demographic strata. Um, so strata just means the demographic that I really want to make sure I'm representing. So let's say ethnicity is the strata in question. So I'm running some kind of study and I want to know whatever it is I want to know, and I want to make sure my sample is representative of the split, of the different demographics of the population. Okay. So let's say the population is whatever 60% or so white. Well, then obviously in this example, I want my population to be 60% white. If it's um, this number African American, I want my sample to be that too. So that's the example we're working with. So when there's a specific, again, demographic that you want to really focus on being representative of, like in this example, ethnicity, you can use stratified random sampling. So in this case, you're taking a random sample from each stratum in proportion to the makeup of the population. Okay, so example, again, if my population is, these are just arbitrary numbers, just to help it make sense, by the way. Let's say it's 6,800 white people. Well, I want my, and 2,000 Latinx. Well, I want my sample to be representative of that. Again, these are not real numbers, just examples, but say my total sample is going to be however many people. Well, the proportion should match that of the population. So if the population is, again, let's just say 68% white and 20% Latinx, well, then my sample should reflect that. It should be 68% white, 20% Latinx. Okay. And I'm going to be randomly picking people from that strata, from that demographic, until I hit my numbers that I want. Here's what that looks like a little more practically. So let's say, again, it's in proportion to the makeup of the population. So the total number of, let's say, white people in my sample should be, again, reflective of the percent of white people in the population. Okay. And the total number of, let's say, Latinx in my sample should be reflective, in my stratum of the sample should be reflecting the percent of that in the population. So obviously, if it's, again, 21%, let's say, in the population, my sample should be 21% as well. So just one more example of this. Let's say if I had 200 participants, so 200 people in my sample, and I happen to know that in the population, whatever that is, let's say it's the whole US, is 68% white. Well, then I want 68% of 200 of the 200 in my sample to be white, which would be 136. Okay. Let's say the Latinx population, or percentage of the population of interest, is 21%. Well, then again, of my 200 people, 21% should be Latinx. So that would be 42 people in my sample that are going to be Latinx. Okay. And this is kind of a really good method. I guess you could say preferable method in a way, because it results in proportional representation of the strata. Okay. Another method is oversampling. This is when, again, you divide people up based on demographics. And just by the way, this obviously is one example dealing with ethnicity. You might do this for any inequality that you want to make sure you're representative of. So let's say I'm doing some sort of political survey, and half the country, let's say 50% of the country is, or no, let's say 45% of the country is a Democrat, 45% is a Republican, and 10% is other. Well, again, then I'd want my sample to be reflective of that. So if I have 200 people in my sample, I'd want 45% of that 200 to be Republicans, 45 to be Democrats, and 10 to be others, 10% to be others. So just the bottom line is you can do this based on whatever strata or whatever demographic characteristic you identify that you want to make sure you're representative of. Okay, another one is, or again, you could do with age too. Look at the population demographics for age and make sure your sample is hitting that proportion as well. Another one is oversampling. This is when the population is divided into demographic strata again, so dividing up based on some demographic quality, and you are going to take a random sample from each stratum. However, you're not going to make it proportional. You're going to have equally sized random samples drawn from each stratum. So this is what that looks like. So again, rather than our, in contrast to regular stratified sampling, oversampling is when you don't make it representative. So maybe 68% of the population is white. Well, we're not going to do that in our sample. Equal numbers from each strata in our sample. So let's say I have 200 people, or say I have, let's see, we got 6 here. If I had 180 people in my sample, I'd want, I think it'd be 30 from each strata, even though it's not, I'd want about, divided into 6. So if there's 100, let's say there's 180 people in my sample, I'd want 30 from each ethnicity, right? Split it up by 6. And again, it's not representative of the population. See here. So, oh yeah, here's a better example. So if I have 200, I want, because I'm just doing it equally, I'd want, divide that by the 6 different strata I have. So I have 33% white, or 33 people, 200 be white, 33 Latinx, and so on and so forth. For all the different ethnicities, they're each going to have 300 because, again, it's not representative. We have instead equal representation of the strata. So this kind of ensures that all strata are included and different. It's different from random sampling because some groups may be over or underrepresented. So this can have various functions. So one thing you may want to use this for is if you're actually interested in comparing differences among strata or among groups. So let's say I wanted to compare, attitudes towards some issue between older and younger adults or various age groups, then I might actually want equal strata because I'm actually interested in comparing them. So I want an equal number per condition, something to that effect. Okay, I think the last one is cluster sampling. This is when you're dealing with populations that are very large, and the unit of sampling is a group rather than an individual. So you might pick a whole class instead of a student. Let's say you're looking at something to do with education, rather than picking one person from one class somewhere and one person from a different class elsewhere. You're just going to pick a whole class. Or maybe 10 classes from a particular school district. Okay. But then bottom line is that the unit of sampling is going to be groups. So you're randomly selecting groups rather than randomly selecting individuals. And this can kind of cross with, a lot of these methods kind of cross with each other. So you could use cluster sampling in combination with, say, other methods like oversampling or stratified sampling or random sampling. Okay. Quick water break again.